Welcome to today's presentation on the fascinating and essential field of thermophysics. In the realm of science and engineering, thermophysics hold a pivotal role, consisting the behavior of matter under the influence of temperature, heat, and energy from the intricacies of everyday thermometers to the profound insight into the behavior of gases and even the design of cutting-edge technologies. Thermophysics is a fundamental science that touches our life in numerous ways. So, without further ado, let's embark on this enlightening explorations of thermophysics. Temperature, where we will unravel the mysteries of temperature, heat, and energy. Let's look into the first topic about thermophysics. Thermophysics is a branch of physics that focuses on the study of temperature, heat, and the relationships between energy and heat. It explores how particles at the microscopic level interact and exchange energy as heat. It is particularly concerned with the behavior of matter as it relates to temperature changes, heat transfer, and thermal equilibrium. Let's look into the state of matters. The characteristic of solid in terms of the intermolecular spacing, solid, if more relatively small, highly ordered and densely packed, held in fixed position. In terms of the intermolecular force, it more relatively strong. These forces holding the particles or molecule together closely packed, ordered, and structured. In terms of the particle motion, it just a vibrate and fixed position, and volume is considered solid is a definite volume, and it has a definite shape and closely packed. And in terms of the compression, it is considered like not compressible. Meanwhile, in liquid, in terms of the intermolecular spacing is greater than solid, molecules are enclosed, free to move past one another, not as densely packed as in solid, and intermolecular force are moderate in strength, falling between the stronger found in solid and weaker forces present in gases, molecular in close proximity while allowing them to move past to one another freely. Particle motion in liquid is a slide past one another, and in terms of the solid, is considered definite volume, and shape, no definite shape, closely proximity not fixed. And in terms of the compression, liquid is nearly incompressible. Gas. Intermolecular spacing is relatively large compared to solid, as in liquid. Molecules are widely separated, high degree of freedom to move. In terms of intermolecular force, in gas are generally very weak compared to solid and liquid. Molecules are widely separated and have high degree of kinetic energy, which is allow gas particle to move freely and independently. And in gas, particle motion are independent and random motion, and no definite volume, no definite shape, fill entire volume container, and gas is considered highly compressible. Simple kinetic molecular, if you look at the temperature of the gas, is a measure of the average kinetic energy of its individual particles or molecules, and it represents the degree of thermal energy which is processed by the gas particle. And as the gas gets heated, their temperature goes up, they move faster, causing kinetic energy increase. In terms of the pressure of a gas molecules are in a constant state of rapid motion. They tend to collide with each other and wall of container. Through this collision, they exert a force on wall and one another, force that exert over a unit area which is defined as pressure. Pressure based on the temperature law, the pressure-temperature law describes the relationship between the pressure and the temperature of a gas when its volume and the amount of gas are held constant. Based on the law, temperature law, it states that the pressure of the fixed amount of gas is directly proportional to its temperature when the volume and the quantity of a gas remain constant. As the temperature of a gas increases, its pressure increases proportionately, and conversely, as the temperature decreases, so does the pressure. Let's look into Brownline motion. Brownline motion is a particle moving in a zigzag manner, and it is a phenomenon named as Brownline motion. From the experiment, large size and less the smoke particles are susceptible to the constant collision with the lighter and tiny particles, which is leading to random nature of observed motion. The diagram of the Brownline motion as displayed below. Evaporation. What is actually evaporation? Evaporation is a process by which the higher energy particles near liquid surface escape into surrounding atmosphere. After absorbing enough energy from surrounding to break intermolecular bond to bind them, liquid particles near surface obtain energy through collision with the surrounding air molecules. Kinetic energy of liquid molecule is directly proportional to temperature of liquid. The liquid molecules with higher kinetic energy escape. The remaining molecules have lower kinetic energy. As a result, the average kinetic energy of all molecules in liquid falls and temperature of liquid drops. The effect known as evaporation cooling. Let's look into what are the factors affecting evaporation. You can see from this diagram, the factors that affect evaporation consist of three main items. One is a surface area, second is temperature, and third is humidity. Let's look how the temperature affects the evaporation. As temperature arises, kinetic energy of fluid molecule near surface increase. They are more likely to break intermolecular bonds and escape, hence increase the rate of evaporation. Secondly, how the surface area affect evaporation. Large surface area where greater number of molecules evaporate. And thirdly, how humidity affect evaporation. High humidity condition, high concentration of other substance in the air, hence lower the rate of evaporation. Pressure, volume. The association between pressure and volume while keeping temperature and the amount of gas constant state that as the volume of gas increase, its pressure decrease, and vice versa, as long as other factors remain unchanged. Thermal properties is thermal expansion of solid liquids and gases. Thermal expansion is the tendency of matter like solid, liquid gases to change in volume or dimension in response to changes in temperature. Let's look under solid. When solid are heated, the average kinetic energy of the atoms or molecule increases, which is causing them to vibrate more vigorously. This increased motion leads to the expansion of the solid, causing it to increase its size or volume. Different solids may have varying coefficients of thermal expansion, which determine how much they expand for a given change in temperature. Meanwhile, in liquids are experiencing thermal expansion when heated the molecules spread apart, causing the liquid expand. This property in liquid is used in the applications like thermometer, where the expansion of the liquid, usually mercury, is used to measure temperature. Finally, we have gases. Gases expand significantly with temperature changes. The kinetic theory of gases explains this behavior. When gas molecules are heated, they move faster and exert greater pressure on the container walls, causing the gas to expand. Let's look at the measurement of temperature. We have thermometric property. Thermometric property is a physical property of a substance that is used to measure temperature. In other words, it is a property that changes in a predictable way as temperature changes, which is allow us to create temperature measurement devices and thermometers. The most common thermometric properties is the expansion or contraction of a substance which changes in temperature. Properties of a thermometer, there are two factors. One is sensitivity and the other one is a ranger. Sensitivity is the ability to measure small variation in temperature. Meanwhile, ranger is a temperature value between maximum and minimum. Marking thermometers scale is a ranger. If there is an increasing in the sensitivity of the thermometer, its range will decrease in the response and vice versa. This is the comparison of alcohol and mercury thermometer. Let's look into what are the advantages of using mercury thermometer. One, it's silver in color and easily visible. Second, it has regular expansion and it don't stick to the wall of the thermometer. And fourthly, it can be measured wide range of temperature accurately and precisely. Besides advantage, thermometers also consist of disadvantage of using alcohol thermometer. Firstly, it's a colorless and could not be easily seen. Secondly, easily evaporate and unable to expand at a regular interval. Thirdly, wet the wall of the thermometer and stick to it. And fourthly, its alcohol thermometer cannot measure high temperature due to its low boiling points. And beside that, before I end the comparison of alcohol and mercury thermometer, you need to take note that mercury thermometers also consist of some advantages of high price, inability to measure very low temperature, and it is poisonous. Thermocouple. Thermocouple can be used to measure high temperature, and it is an electrical nature of its mechanism, which is enabled to detect rapid temperature changes and measure with meter. And it consists of two conductors of different metal alloy, which produce voltage in vicinity attached to meter. And the meter is used to calculate temperature differences. And let's look into the thermal heat capacity. What is a thermal heat capacity? Thermal heat capacity, all particles within a body or system processes kinetic energy due to their motion, and because of intermolecular forces that bind them, they also process potential energy. The total energy is the sum of all particle kinetic and potential energy, and the total energy is known as internal energy. When heat energy is supplied to a system, its temperature rises, kinetic energy and speed of particle also increases, which causes an increase in internal energy of the system. In order to measure of heat energy, needed to raise the temperature of the system. Specific heat capacity is defined as the energy required to increase the temperature of 1 kilogram object by 1 K. Let's look into this simple, that so-called formula, where H is actually represent heat energy in joule, M is actually mass in kilogram, C is actually specific heat capacity, and T triangle is actually represent temperature change. So the formula is heat equals to MC T, means that mass multiplied by specific heat capacity and multiplied by temperature change. With that being said, that's all for today's presentation. Hope that you enjoy with today's presentation and understand the topic, and hope to see you in the next presentation. By the way, please don't forget to subscribe to Jom Stabila YouTube channel. There will be a lot more new presentation and new topic will be uploaded in this website or YouTube channel, Jom Stabila YouTube channel. Thank you very much for listening.